So now, what if we're given two sides of just a right triangle? If we know that c squared equals a squared plus b squared, where a and b represent the side lengths of a right triangle and c represents the longest side of a right triangle, how can we find a missing side if we know two of the sides? Well, we use Pythagorean theorem. Pythagorean theorem says that c squared equals a squared plus b squared, and c represents the hypotenuse, a and b represent the legs. And you can recall this from the vocabulary where a and b were the legs and c was the hypotenuse. And again, if you can't remember the word hypotenuse, just remember that c represents the longest side. Let's go ahead and do an example using Pythagorean theorem. The first thing I do is I always write c across from my right angle. That's my hypotenuse. And then a and b, I'll usually make the smallest of the two a and then the middle of the two b. Kind of like to go in numerical order with my letters. So the formula is that c squared equals a squared plus b squared. And we have a and b, we're looking for c, which represents our hypotenuse. So I can interchange this c with x, and I'm squaring it. Set that equal to a squared, which we said was 3. So it'll be 3 squared plus b squared, and we said b was 4. So 4 squared. Now if you can't do 3 squared in your head, 3 times 3, you can use your calculator, and that's 9. So we have x squared equals 9 plus 4 times 4, which is 16. 4 squared is 16. So that leaves us with x squared equals 9 plus 16, and 9 plus 16 is 25. And now I want to solve for x, which represents the hypotenuse. So I need to get the square root of x squared. That's how we'll undo x squared and leave it as just x. And what you do to one side of an equation, you have to do to the other. So the square root of x squared is going to equal the square root of 25. So this square root is going to undo the squared number. So x will equal the square root of 25. Square root of 25 means what two numbers did I multiply together to get 25 that were the same numbers. If you don't know your perfect squares or you don't know square roots, you can just type in the square root of 25 in your calculator and it'll give you 5. And then what I do is I go back into my original equation and I make sure that 5 squared equals 3 squared plus 4 squared. So we said that 5 squared was 25, and that should equal 3 squared plus 4 squared. And 25 equals 25. So we know that we solved for the missing side correctly. Okay, now we're going to do another example where we're looking for x. Again, we're given 2 out of the 3 sides of a right triangle. I automatically label c as my hypotenuse. A and B, I don't know which one's A and I don't know which one's B, but just by looks, I'm going to say that this is the shorter of the two. So I always write out my formula. C squared equals A squared plus B squared. This way it's just a matter of taking the number and substituting it in as I see it in the original equation. So C squared would be 10 squared, and that should equal A squared, which is 6 squared, plus B squared, and I don't know what B is, so I can just call it x squared. 10 squared is the same as 10 times 10, which is 100. 6 squared is 6 times 6, which is 36, and I don't know what x squared is, so I leave it as x squared. This is just the same exact thing as solving for x. X squared is the same thing as solving for x. You're going to do the opposite operation to move your x's to one side and your whole numbers to the other. So first thing I'm going to have to do is subtract 36 from both sides of my equation. So I get 64 equals x squared. Again, I'm solving for x, not x squared. So I'm going to undo my x squared. So that's the square root of both sides. So I would square root my x squared, square root my 64, and the square root of 64 is 8, and the square root of x squared is x. So my missing side is 8. And then the last thing I do is make sure that, oops, I put it in the wrong spot. There we go. So then last thing I do is make sure that these numbers match my original equation. 10 squared should equal 6 squared plus 8 squared. So we know 10 times 10 is 100. Does it equal 6 squared plus 8 squared? And it's also 100, so yes, it equals 100. So yes, we did this properly. Okay, so the same type of equation, we're using Pythagorean theorem. We label our sides a, b, and c, and we use Pythagorean theorem, c squared equals a squared plus b squared, to solve for x. Go ahead and pause the video and see if you get the same thing that I do for the value of x. Okay, if you didn't get x is 9 and you're not sure why, go ahead and raise your hand and we'll come by and help you. Okay, and I'd like you to try one more Pythagorean theorem. Now this time they only gave us 3 as a measurement and x as a missing side. Actually, let's turn this into a right triangle. And these hash marks mean that this side and this side are the same. So even though it looks like they only gave us one piece of the missing side, we know that both of these are 3. So I'd like for you to pause the video and see if you get the same thing I get. You are going to get a decimal, and I'd like for you to round to the nearest tenths. So you should have gotten that x is 4.2. If you didn't, raise your hand and let me know, and I'll be happy to help you.